The broadcast is now starting. All attendees are in listen-only mode.
All right, guys, welcome back to another KevCAM night class tonight. I don't have my normal screenshot on here because I switched computers, so I'll have to get that transferred over. I just noticed that now. But for those of you guys that are new to, I do see one kind of new name in here. For those of you guys that are new to the night classes, these night classes are solely dedicated for you guys, and you know, tips, tricks, and everything in between in there for SolidCAM for you guys. So tonight I have Andrew helping out with any questions, concerns that come up along the way for you guys. Andrew, are you with us?
Yep, I'm here. I will not be answering them. I'm just going to let Kevin know that he needs to stop what he's doing and answer them. Because if I was answering them, this night class would be very, very short. So.
No, and for those of you guys that do have questions, definitely feel free to type those in. And what we do is we use GoToWebinar for these live broadcasts for you guys. And there is a questions panel, and I took a screenshot for you guys, so you guys should be able to see my screen right here. If you guys hit the little arrow out for the questions right here, and you guys should be able to type those questions in, and Andrew will tell me to shut up and answer Ronnie's question, and we'll keep going from there. And then, like I said, guys, these night classes are just as a training purpose for you guys. So if you guys do have suggestions or ideas of what you want to see in there, definitely shoot me an email, and I will implement those in right away for you guys. And for those of you guys that don't have my email address, I just put it into the chat area for you guys, so you should all see that. Now, every night class is being recorded for you guys. So you can see here on the YouTube channel, it's called SolidCAM University, or if you guys do a search for KevCAM, either one will pull up with my ugly mug here. And every night class is recorded, and we're also doing some short videos in there as well. So I just did one last week on, using SolidCAM for a laser or plasma cutter or a water jet machine. But there are also some short videos that Mark Pimentel does a great job for you guys too. So let us know what we can do to help you guys out more than anything. And I will give you the link for this YouTube video. So there is the link to the YouTube video, and that should take you directly to the channel here. All right, I think we're ready to get the ball rolling here for you guys. So let's hop over and get into our mill turn part. So tonight we're going to be covering kind of the basics of what we've been doing all along with the mill turn. But now we're going to get a little bit more advanced stuff. We're going to do some balance roughing in here. I'm going to do some transformations in here with iMachining, and doing an MCO to transfer from the main spindle to the sub spindle, and then we'll start machining on that sub spindle for you guys. So, all right, guys, so let's get the ball rolling here. So first thing I'll do is just do kind of normal facing. So we'll just kind of walk you through the steps. Now, for those of you guys that were here last week, are you guys liking when I simulate after each operation so we can kind of see what's being done? Okay. Ronnie, your answer is good as gold, so I'm going with your answer. And Greg, okay, perfect. All right, so we'll do a facing operation here. So I'm going to start off with my Mac 1, position 1. I'm going to use my left side and use the spindle. I'll show you kind of what I mean by that. So I'm going to grab some geometry real quick. Hit the green checkbox. And tool now. And basically what I was telling you with the spindle on the left side is, where is that tool located? Is it located in this is a Integrax machine, so we kind of got that 5-axis head up on top, or are we doing the turret on the lower side? So we will grab tool number 6 on that main spindle, and you can see that I'm pointed in the right direction, so we don't have to mess with my tool orientation here at all. Levels, going to be the same as what we've kind of always covered for you guys. Technology, we're doing facing. I forgot to do a extension. So let me do an auto extension to my stock here, and that's right down here at the bottom. So basically, I just told it to extend that geometry to the center point of that material instead of just going to the end point right here. All right. All right, so we're doing facing. We'll do finish and save and calculate. Toolpath looks good. Let's go ahead and simulate this, and I'll do this one in turning. And like I mentioned before, the turning one is kind of golden for any time you're doing turning, but as soon as we get into the mill turn side of things, then we're gonna want to switch over to that solid verify or that machine sim for you guys. All right, so we got our part faced off. We're good to go. So now, this is a little bit of review from when we did balance roughing before, but so what we're gonna do is turn this geometry right here, if you're following my mouse, with the upper turret and the lower turret at the exact same time. So what I'll do is do balance rough, and we're gonna use our Mac 1 position one again. Now, my master, I wanna use my left spindle, and the slave, I wanna use the lower left spindle, or the turret, I guess you could say. Let's go and grab our geometry. So what I'll do here is, let me kind of zoom in and grab that first little piece, switch that arrow so it's going the right direction for us. And I want to end over here so we can see our nice yellow line that's highlighted. And for those that are new, like I said, I do see a couple new ones in here. This green line right here is representing our updated stock. So this is what our stock looks like right now. So we'll go ahead and accept that. And so our main tool is going to be our tool number 6. And I'll orientate that so it's going the correct way. And our slave tool right here is going to be tool number 1. Now with that slave tool, just imagine it's going to be up on the upper side, because right now you guys are looking at it with the insert pointed down, and if that's over here on the bottom, that's not going to make sense. But like I said, with that slave tool, just imagine that it's on the top, and then the SolidCAM will automatically convert it around for you guys. So we'll do levels are the same as normal. We can do, and like I said, this is a little bit of repeat, but we can do simultaneous, so the roughing and the finishing is going at the same time, or we can do trailing. And we'll just kind of go through them real quick. And strategy, we'll do non-deciding so it doesn't go inside that groove. And let's just do save and calculate. And I'll show you our differences here. Let me switch up my general here. And I'll take a little bit heavier cut than the 40 thou. Let's do 90 thou. All right, so let's go and simulate this. We'll do a turning. So right now, the upper is taking 40 thou, and the lower is taking the leftover 40 thou, I guess you would say. I don't know what the best way to explain this. So this one's taking 40 up here, and then the following tool, the slave tool, is coming in and taking an additional 40. So they're doing them at the exact same time. So as they're playing through, you can see going along. So if I wanted to, what I could do is when we're on general right here, we can do a trailing, and let's say I wanted to trail behind by 250 thou. Save and calculate. And let's do turning here. And you can see right here, so we can updating stock right here from that upper, and then we're cutting on that lower at the same time. All right. So now we got that part roughed out. So we just need to do a finishing pass on there. So what I'll do is do save and copy here. And then I'm just going to switch this back over to a standard turning operation. So all I have to do is just click the green arrow, and it's going to convert it over to a standard turning operation. And we'll just turn on a finishing pass. So I'll just do an ISO turn method here. Save and calculate. Turning. And we just cleaned up what was left over from that roughing pass. Now, for those of you guys that that weren't here for a couple of turning classes, why did I turn on the non-descending? Let's just show what it's going to look like when it's on, or off, I should say. So it's going to try to get in that groove as much as possible. Now, obviously, with that insert being so large and with the angles, it's not going to go in there. So I'm just going to save that for my grooving tool. So what I'll do is, that's why you can turn on the non-descending motions, and it's going to skip over those areas for you. So now if we just play that through again here, now it's skipping right over our groove that we're going to be doing there. All right, so we got that outside profile finished. Let's go ahead and let's work on our internal. So let's go to drilling here. And this one is going to be on the lower. So I'm going to switch this over to the lower left. Go ahead and grab my drill. Do tool number 3. Levels. Same as our safety. I should really just start skipping over this one for you guys. Probably getting sick of looking at that screen. All right, so what do I want to drill off to? So I'm going to do my endpoint, just highlight and click on the vertex or a face, doesn't matter. And let's just go a little bit past. So let's do 100 thou. And we'll do a minus 100 thou here. And I want to do full diameter. And let's do a pecking, and we'll do a 200 thou peck. Hit OK. Save and calculate. And let's take a peek at what we've done. And I've offsetted it. What did I do here? Oh, I did a center shift. Sorry about that, guys. So I'm shifting it off center here. Don't want to do that. We'll leave that right on center, and we'll do a minus 100 thou here. All right, now let's try it. The great joys of having simulation, I can see exactly what's going on. Perfect. So we got kind of the majority of the material drilled out there. So now, let's go ahead and do, let's see, let's do the groove. So we'll go ahead and do our grooving here. And grab our geometry. Like I said, that green line is kind of representing our updated stock. So I want to just grab that and groove out that area. Now, I have to remember here, I think I'm on the left spindle. See if my tool's there, my grooving tool. Yep, perfect. And just orientate that to the correct position here. Now, if you guys are, you're looking here and say, well, what if I want my grooving tool to be at an angle? Just get the one that's closest to it, and then what you guys can do is add that additional angle in there, and then it will shoot it over however many degrees that you need it to. But for this specific one, we're just coming in there straight, so I'm just going to leave her straight up and down. Technology, doing a grooving. And let's go ahead, yep, it's got the ISO turn on, save and calculate. And I'm not really setting up my step downs, I'm kind of leaving what the default is here, but just because it depends on the material that we're cutting, the insert that we're using. But as you can see, let me slow it down a little bit here. Just getting all that material out of there. And we do have a lot of parameters here for you guys for the roughing strategy, if we want to do it by rows or columns, if we want to do side to side, zigzag, middle out, alternating. So there's a lot of different passes here. And I did go through all this in pretty fine detail when we did the grooving. So if you guys have questions on kind of what the rows do versus the columns versus what all the different strategies here do, definitely check out the turning grooving night class video and kind of go through that in great detail for you guys. Okay, so let's go ahead and bore out. Let me turn off all this toolpath here. Let's finish our inside bore. So we'll do a turning. And we'll just grab that geometry right there. And that's what we have left for our bore. And I'm going to also extend this past by 100 thou. So I'll just put a 0.1 extension on there. And you guys should see, if you guys are kind of curious on if you should have a negative number in there or a positive number, just type it in there and hit the tab key, and the yellow line will extend to show you exactly what's going on. All right, so this one's going to be actually on the lower left. And we'll go to Tool and grab our boring bar here. There it is. Technology, do an inside bore, doing a 20 thou offset for a finish pass, stepping over by 40 thou here, semi-finish, or a finish, sorry, and we'll do turn method, save and calculate. Let's see what we got here. And that finish pass here. And, you know, the only reason I'm going past is I don't want it to end right on this point right here, because when we go to switch this part from the left spindle to the right spindle, I might have a little nub right here if I'm not going far enough past. So I want to definitely go far enough past that I know I'm going to have a clean cutoff or a clean face on that when we go to that second op. Okay, let's see. What do we have left here? Our threads. Right here, I got, it's not representing the threads here, but doing a 1 3/4 by 8 thread on here. So easy enough. Let's go to threading. And I am going to be on the left spindle, is where my threading tool is. Grab our geometry here. And just grab that single line right there. Go ahead and grab our tool here. And that looks like our threading tool right there. Orientate this to the correct orientation here. Levels we'll skip over. Doing threading here. I'm going to set this up to take, say, 35 thou step down. Since we're doing the 1 3/4 by 8, so I'll just put 8 in there, and my minor diameter is going to be 1.9774. Well, let's just do 978. Round it, and that should be it. Save and calculate. Turning. And we got our threads. Okay, so let's get, so this is a little bit of repeat here, but let's get into some more interesting stuff here. So now what I'm going to do is I want to drill my holes going all the way around here. You can see I have a bunch of holes going all the way around. Now, 2 ways of going about this. What we could do is do a standard turning operation and do the 4th axis. Or what we can do is do our multi-axis drilling. So I'm going to go to my SolidCAM multi-axis tab right here, and we'll kind of cover this in the simultaneous 5-axis stuff. But we'll just click on the multi-axis here, and It's going to be in my spindle, because obviously we have to spin that because it's a drill bit. Geometry. I'm just going to do find holes. So in here, you can see it's got all my holes. Now, my shape 2, I don't really care about that hole anymore because I already drilled it out. So I'm just going to come in here and remove. So now I can see all my holes. Always make sure those are pointed in the right direction. So we want the arrows coming out, just like when we are using HSS. You want to make sure those arrows are going the correct direction. So we'll go ahead and accept that. Tool. And okay, there we go, our 2-or-1 drill. Levels. Since I'm not working on a flat part here, we're working on a round, so we'll switch it over to cylinder. And what diameter do we have right here? Millimeters. Let me just switch this setting up here. Document, units, inches. Can't get to the bottom. There we go. Okay, that's still given to me in millimeters, so I might have to close that here. Let's just try 3 inches for right now, or a radius of 3 inches. Okay, so we're parallel to Z, looks good. We're going to do a drilling cycle here, and we'll do a 150 thou step down. Now, depending on your guys' post, you guys may have to enter this as a QPEC. If you guys enter this in as a QPEC down here, which a lot of the posts are set up, but some posts are set up just for the step down, you may not see it in the simulation PEC. So if you guys want to see it in the simulation, you'll want to do it under the step down and the QPEC to see the full simulation. Tool axis control, output in 5 axis. Gouge check, don't have to really worry. Let's save and calculate. And let's take a peek. So now we're going to switch over to the solid verify here. And I'm going to zoom out here. And that was really fast. So obviously I can switch up my levels because we're starting fairly high here. But you'll notice that I didn't tell it how deep to go. So it's pulling the geometry from that drill hole, and it knows exactly how deep it needs to go to achieve that depth. So I guess what I would do here is go to my levels. Let's switch this over to 1.5. That's too narrow. So now we're not starting so far up in the air and coming through and drilling out those holes. Okay. Now we're going to mill out our pockets right here. So what I'll do for that is my good old iron machining here. Now in here, let me kind of get my stuff zoomed around here. You'll see my Z is pointing out. And I want that Z to be facing up along with my flat face right here because that's the machine surface I want to work on. So what I did is I set up a Mach 1 position 2 here. And now you'll see my Z direction is exactly perpendicular to that flat face. And so, and I kind of talked about this, I think it was last week or the week before, creating those coordinate systems. Putting those on there is when you guys want to keep that orientation in the center, but off of a surface. Here, I'll just go to it for you guys. Hit the wrong button. So let's say we're adding one in here. Thing you want to keep is keep this at chord sys 1. So by doing that, I can click on this face up here. It's going to keep my coordinate system at the center, but it's going to align the axes with that flat area right there. All right, so we were Mach 1 position 2, new. grab that face right there, and I'm going to do a semi-open pocket, so I will do mark open edges. And we'll go ahead and grab our tool here. It's going to be tool 7. And we'll do a pocket depth up to right here. And I rough plus finish. And we'll go with level 8 here. Let's go ahead and save and calculate here. And we'll do a solid verify. Make sure we're on size here. Looking good. Looks like my thread might be a little off here. I don't know why the solid verify. I'll have to check later on and see if that's correct. All right, so we're good now. Now, 2 ways to go about this also is we can have a coordinate system for each flat face, or we can take the hit the easy button, I guess you could say, and let's get back in there. And I'm going to hit the easy button, also the transform, and I'm going to do a round 4th axis, include my original, and I have, what do you have? 1, 2, 3, 4, 5 of these pockets. So take 5 divided by 360. It's going to give us 72 degrees. And since I already got my original in there, I'm going to insert 4 more. Hit the OK. Save. And do solid verify here. Whoops. And see what we got. Now on solid verify, we're not going to see that spindle rotating. You'll just see the tool kind of going around. I'll play this through in machine sim for you guys so you can see what it looks like once we're all done here. All right, so what do we have left? Can't remember here. Let me play this through one more time. Speed it up so you don't have to wait for it. All right, let's do our execute. Looks like we're orange and yellow and just a titch of light green, so that we're within 4/10, and I'm see what my accuracy is. Yeah, I'm right on 4/10 accuracy, so we're up to size everywhere. Looks like I have a little bit of material on the floor from my eye machining. Ronnie's yelling at his phone right now. Kevin, you forgot the floor. I'm just kidding, Ronnie. I'm actually, because I really don't care about the floor finish on this one, I'm just going to switch this on to 0. Simulate. Okay, now we're getting green. I'm going to see if we got anything else. Check our holes real quick. And what's going on here is, if you look down here, we do have a titch of dark blue in there, but my drill point has gotten down to the exact point. So what's actually representing here is these were flat holes in here, and we're using a angled hole. So we can come back and do it flat. We're pretending that Ronnie's the engineer and said, nope, I'm okay with a angle on there. Don't worry about it. Okay. So we're good. So now what I'm going to do is do a transfer. And I got tool path right here. Okay. All right. So what I'm going to do is, if you guys have a main spindle, sub spindle, and you need to transfer that part from the left spindle to the right spindle. Let your post guy know, and what he's going to do is he's going to create a MCO, machine control operation, for that. And I was going to kind of go through and show you guys on creating a MCO, but it's so different between machine to machine and so dependent on the post processor. So what I'm going to do is I got a machine control option right here, and I'll show you how to do it. But what I did is I saved it out as a template. So I'm pretending that I was the customer for you guys, and this is what I got from my post guy. And then I'll kind of bring you in through it. There's one other thing I was going to talk about. Oh, completely off subject, but we had a question last week of what does the MAC stand for? And I can't remember who asked that question last week, but the MAC stands for machine orientation. It's just shortened up. I was thinking it was something else, but I've been told from the higher ups that that's what it stands for. So whoever asked that question, I apologize, I can't remember who it was, but that's what the MAC stands for.
Sounds like a pretty good question. I would call it MO from a layman's standpoint, machine orientation. So, I mean, whoever asked it,
that's
legit
too. But with being that MAC, I was kind of thinking, maybe machine coordinate system. Machine absolute coordinate kind of deal, but nope, machine orientation is kind of what it goes for. Greg, was that you that asked that last week?
Pipe up, Greg.
Yep, okay. All right, perfect. No, that was a great question. You had me a little stumped on that one. I had to do some deep digging on that one. All right, so part transfer. All right, so like I said, I added this as a template, but what I'll do is I'll kind of show you it. So I'm going to go down to my part transfer right here, hit OK. Voila, it transferred over. So here is what's inside the MCO, and this is, like I said, this is very post specific here. But what we got kind of going on here is the start definition. Kind of, what's going on with that, the left spindle here, what coordinate system is it on. Then we're going to move the B axis out of the way. We're going to move the lower turret out of the way. Left spindle is going to come to a stop for us and going to orientate the spindle, so it's going to align everything. Right spindle is going to come over, clamp on the stock. Left spindle is going to open the jaws. Right spindle is going to move back to its original position. So that is an MCO. And like I said, you guys don't have to worry about creating this because this will come from your guys' post. But this is how doing a part transfer, doing a parts catcher, bar feeders, all that stuff is all written into the MCO for you guys. And like I said, you guys don't have to go through the hard legwork of figuring out what to do. This is, let the post guys will have this out for you. So any questions on just the kind of the MCO? Easy. Love it, Ronnie. Okay. So now we've transferred that part over to the other spindle. So now what we have left is, Ronnie, you pointed out I forgot about the QA cutter in here. I don't even have a QA cutter in there yet. So I'll finish off. No, next week we'll do a QA cutter for you. How's that sound, Ronnie? Apologize. Okay, so now we're over in the left spindle. So I have a Mac 2 setup for this one. So I will go back to my turning here. And we're going to switch this over to Mac 2. And then I want to use my lower right and we will do that geometry. Oops, forgot that green check mark. And we'll do a modify, and we'll set up our auto extend to our stock. Grab our tool here. And then go tool 8. And like I said, we want to pretend that this is on the upper, kind of same thing here, but I'm going to flip my insert around so it's going the correct direction. Levels, not going to worry about. Now this one, it gets just a hair. I got a little stumped on this one myself. So normally, since we're doing a turning operation here, we would do front face. Now, let me just kind of play this through here and let me get everything kind of set up. So I want to do ISO turn. And now since I'm on my sub spindle, I don't want to go from my right safety corner. Definitely is going to hurt me out there. So I'm going to go from the left now. And let's save and calculate. And I want to play this through to kind of show you guys the difference here. As you can see, this is not what I'm looking for. It's kind of going completely backwards from what I'm looking for. Well, in SolidCAM's eyes, it is seeing this as a back face because we're kind of doing the back face here. So that one is a little bit on the confusing side, even for myself. So if we switch this over to the back face here, save and calculate, take a peek now, we should be looking correct. So now it's doing exactly what I'm looking for here. And you can see we're automatically adapting that tool path, so we're not cutting air going all the way down to uncut material for you guys too. And you can see our jaws are over on the right-hand side clamping onto those threads. All right. Any questions so far? I don't see anything coming up, but now let's get to the cool stuff here. Let's do simulate and machine sim. And again, this is on the Intergrex, and sorry guys, I have a little man crush on the Intergrex machines. They're one of my favorite ones. But Ronnie, you did have a really cool machine. I just don't have the the CAD drawing for it. Okay, so we're starting at the very top, kind of going through exactly what we all did here. So let's go ahead and play it through. So we're facing, we're doing our balance roughing now. Finishing it, doing our drilling, doing our groove, boring it out, threads, doing our multi-axis drilling. Kind of zoom in here for you guys. Oops. Now this is where I'm talking about, like with the Solid Verify, you just see the tool rotating. Now since we're running Machine Sim, we're actually seeing the spindle rotating for us. Okay, so now we're going to start our iMachining here. I'm going to speed this up a little bit. So we got one slot done. Two. Three and Sorry, I'll stop counting. All right, so we got our last one here. And I'm going to slow this down. And I want to give you guys a good picture of that part transfer. So we're just kind of polishing off that that last eye machining here. Looks like I slowed it down a little too fast or too slow. Okay, so we moved that spindle out of the way, lower turret out of the way, and spindle came over, grabbed the other side. Now we're finishing off our part now. I kind of get a zoomed in chunk here. And there we go. What do you guys think? Andrew said it's easy peasy, and he could show me up on this.
I've already done it many times. I would have had this done a long time ago.
All right, guys. Any questions? Got a couple thumbs up, couple cool. Let's see. Will you be showing how to handle a tool conflict in the future? Tool conflict as when it was, right, Ronnie, were you talking on the main spindle when it was showing red there? Turret interference. Yeah. And that's going to be under the channel synchronization, and I'm going to cover that next week. I have a part, and all of you guys have this part. It's actually the advanced part in your guys' install. But I'm kind of going through the channel sync. I don't want to get too in depth here just because there's a lot going on the channel synchronization, but I'm going to go through it as much as I possibly can for you guys. Some of this channel synchronization is a little bit over my pay grade. May have to get Greg Payton to show that. No, I'm kidding. We'll have to get. I'll try to focus as much on it as possible for you guys. But if there is any unanswered questions, what we'll do is we'll create a shorter version of that video too. So, but all right, I don't see any
extra credit for you, Ronnie, if you teach it.
Yeah, there you go, Ronnie.
Next time, extra credit. All right, I'm throwing it out. Just kidding. I have no authority.
No, it's great working with you guys. I love all the comments and love giving you guys good grief. And Ronnie, I love talking with you on the phone too. But no, I don't see anything else in here. So I think we'll kind of wrap it up with that for tonight. So next week, yeah, you're absolutely welcome. Next week, we'll be going into a very, very advanced mill turn. I think it's the most complicated mill turn part that we could possibly find. So we'll be kind of going through that step by step. And then after that, we are going to be going into Sydney is going to come in and do kind of sneak peek of 2018 for us. And then after that, we're going to kind of touch on, Ronnie had some ones with the SolidCAM AFRM. I kind of forgot about these. So we'll do pocket recognition, drill recognition, chamfer recognition, and the hole wizard recognition. On the hole wizard, I think I'm going to try to bring in Ken Merritt. He is one of the developers that actually developed this. Ken and Sydney did a phenomenal job. So it pulls the data from your hole wizard in SolidWorks and automatically will add that drill bit in there, or a spot drill tap, making things really easy. And they are actually adding on to this quite immensely. And we'll kind of talk about that maybe when Sydney comes in, some of the new features that they're working on, and they're trying to get launched by SolidWorks World, which is May. Andrew, when is the SolidWorks World? May, or SolidCAM World? 28th, was it?
I was just going to say, SolidWorks World End. Yeah, it's May 28th through the 30th, I believe.
Okay. So we're trying to get, or I shouldn't say we're, Ken and Sydney are working very hard to get that, some of those new features added in there for you guys. So let's see.
Looks like there's another question in there, Kevin.
I can't remember. Did you ever go over, or if it's even possible, broaching? Yeah. We did go over broaching in the milling. That was actually under the toolbox cycles night class. But let me just take a peek at our part for next week. Let me close out of this for a second. And I think we have broaching in there. I'll just take a peek here. I gotta find my Integrix here. Like I said, this is a very large, complicated part here. I think we have broaching in here. I just can't remember. And now it's going to sit and think. Oh, come on. Well, tell you what, George. What I'll do is, if there is no broaching in this next part, I will add it into that part that we actually did tonight, and kind of start off with that for next week. So definitely we'll get that added in there and show you guys. But like I said, if you go back and check out the toolbox cycles, if I go to toolbox, and this one right here, in here, go over broaching, and it's actually this part right here we did the broaching on. So definitely there for the milling. But any other questions, guys? Don't see anything. Kind of quiet crowd. It's all right. All right. Andrew, got anything else before we kind of wrap things up?
Nope.
All right.
Great job, guys.
Andrew, the man of
a round of applause.
Few words.
That's right. That's right. When it comes to mill turn simultaneous transfers, yep, that's going to be me. Few words on that, and I think everybody thanks me.
Yeah. All right, guys. Well, I can't thank you enough for all the great comments. Love talking with you guys on here. Love having you guys sit through these night classes too. Really do appreciate the attendance, and hopefully you guys enjoy them and get something out of them too. Like I said, any ideas coming forward, shoot those over to me in the email. Get those added in there for you guys, and we will talk to you guys next week. All right, guys. Have a wonderful night, and we'll see you guys next week. See you guys.
Thanks. See ya.